Hi, my name is Qiyuma, and this is my screencast for the first project, System Calls. In this project, we're going to add our own system calls to the reptilian kernel. First, let's look at how we set the system call number. So, I modified the file called syscall 64.table. I added 3 new system calls here, 435 for get, 36 for set, and 37 for proclog message. These entries map the system call numbers to my functions. Next, in the syscalls.h, this header file, I declared the function prototypes, and this declares the entry points for the new system calls, so the kernel is aware of them. And then for the implementation, I went to sys.c. At the end of this file, first I defined a global integer variable process log level and initialize it to 0, so we can use it to store the system-wide process log level information. For the first function, getProc log level, it simply returns the current value of process log level. And then for setProc log level, I first check if you are a super user. I used current cred uid.value to check. If it is not 0, it means you are not a super user, and we return to -1 to deny your access. We also validate if new level is between 0 and 7. If so, we update the process log level to new level and return it. Finally, the function proclog message. First, we also do the validation. Then we check if the log level is higher than the process log level. If so, we ignore the message and just return level. Otherwise, we need to log the message. We use the function copy from user to safely log the message, and we use printkey to print the message. We also use current com and current PID to get the executable name and PID of the current process. Moving on to the user space library. Under the process log directory, we have 3 files: the header file, the source file, and a makefile. First, in the header file, I declared all the functions, and I defined the system call number and the log levels. In the source file, the first 3 is library functions. They act as a wrapper and return to syscalls function. This is just to invoke the system calls in the kernel space. Then the harness functions. These 2 retrieve functions, they return to a parameters array. The first element is the call number, and the second parameter is the number of parameters. And the rest elements are the exact parameters. And we have 3 interpret functions. They just return what they get, the same as the system calls returns. In order to test the changes I made to the kernel, I git apply the patch file to a clean kernel. First, I extract the archive, so we have a process log directory. I went into the directory and used make to compile the library. The 2 test programs are also compiled, so we can just run the test. First, the library test, and then the harness test. From the output of these 2 tests, we can see they are all successful.